Today we're going to talk about multiplicities of 0. So before you even start filling things in, I want you to try this first example. So I want you to find the zeros of the function f of x equals negative x to the fourth plus 4x cubed minus 4x squared. Once you've done that, I also want you to find the end behavior of the graph. So that is from 3.2, and that is your leading coefficient test. So pause the video, do those two things, and then come back. Once you're back, I want you to check your answer. So your answer, as you can see, there is two values of 2. So I know my zeros are 0 and 2, and there's two values of 2. So I could have wrote my equation as x minus 2 squared here. Okay, be aware of that. So multiplicity is if a 0 happens more than once, what does that do to the graph? So today we're going to discover how to figure out what's happening in between my end behavior. So this function is an even function because of that x to the fourth, and it has a negative leading coefficient because it's negative 1. So if you think about even functions and negative leading coefficient, that means that both my left and right fall. So what we're going to do today is we're going to figure out, well, what happens in the middle here? So I know it crosses the x-axis at 0 and 2. So finding my zeros, remember that's finding my x-intercepts. So what we say is that if a 0 has an even multiplicity, then the graph touches the x-axis and turns around. So here, if I looked, I'm going to start with x equals 0. So I'm looking at this part right here. So since this is negative x times 2, 0 actually has a multiplicity of 2. What that means is that I know my end behavior has to start going down here. So I'm going to start with my arrow going down like this. That 2 that I circled means that what's going to happen is it's going to touch the x-axis and turn around. So it would look like this. So it touches 0, 0 and then turns around. Now if I look again, I said you could rewrite x minus 2 times x minus 2 like this. So since this has a multiplicity of 2, it's also going to touch the x-axis and turn around. So this is what my graph would look like. So I know the end behavior both go down, and then I realize that it touches the x-axis and turns around. If you had an odd multiplicity, so let's say I had like x plus 1, just that, what that means is that wherever x minus 1 is, it's going to cross this x-axis. So if it has an even multiplicity, it touches and turns it. If it has an odd multiplicity, it crosses the x-axis. So what we're going to do is we're going to find the zeros of this next function and then give the multiplicity of each 0 and then state whether it crosses it or turns around and then sketch the function. So first thing I want to do is find the zeros. So in order to find the zeros, remember we set this whole function equal to 0. And the nice thing about this is that it's already factored for us, so I can just set each component equal to 0. So 1/2 equals 0. Well, I know that's not true, so I don't worry about that. Then I have x plus 1 equals 0, so I know x equals negative 1. And then I have 2x minus 3 squared equals 0. So pay attention to this squared part right here. But I could square root both sides, and then I would just get x, or 2x minus 3 equals 0, so x would be 3 over 2. So because of this 2, this has a multiplicity of 2. If I look at x plus 1, there's no exponent here like there is here. So this is called a multiplicity of 1. So if I wanted to if I'm looking at the multiplicity, well, since 1 is odd, what that means is it crosses the x-axis. Since this has a multiplicity of 2, what that means is that it touches and then turns at the x-axis. So what I need to do is I need to figure out, well, what's happening in the beginning and end of this function. So since this function is being multiplied, I have to figure out the degree. So I know this degree is 1, and then this degree is 2. So when they're multiplied, remember you add them. Well, 1 plus 2 is 3. So this has a degree of 3. So 3 is an odd number, so it has an odd degree. The leading coefficient now is 1/2. 1/2 is a positive number. So recall what a graph looks like if it's odd and positive. If it's odd and positive, it starts falling towards the left, and then we're going to figure out what happens in the middle, and then it ends by rising to the right. So what we're going to do is we're going to sketch this function now. So I know it crosses the x-axis at -1 and at 3/2. Something happens. So I'm going to start with my end. So I know it has to start falling this way. Then I look here. It says a multiplicity of 1. So multiplicity of 1 means it crosses the x-axis. So it goes up and crosses. Now something happens and I know I have to go back to this point. So now at x equals 3/2, it has a multiplicity of 2, which means it touches that point but turns around and keeps going up. So this is f of x. So multiplicity just tells me what happens in between and at those x and y values. So what I want you to do is I want you to try the next two examples. I'll put the answer keys up as well. But we're going to try this last one together. So write a polynomial with zeros, -2 multiplicity of 2, 4 multiplicity of 1, and then 3 multiplicity of 3. So to find zeros, remember if they give you the x, it would be x equals -2. So since x equals -2, that would be x plus 2 equals 0. Well, the important thing here, it says it has a multiplicity of 2, which means I need to put this to the power of 2. So that would be one factor. The next one is x equals 4. Well, x equals 4, the factor would be x minus 4 equals 0. This one had a multiplicity of 1, so I put it to the first power. The last one was x equals 3. So then I subtract 3 over, and then it said it had a multiplicity of 3. So in order to come up with my function, which you learned in the last video, it would be x plus 2 squared times x minus 1 to the power of 1, and then x minus 3 cubed. So what I want you to do, in addition to those two problems, is to expand that. After this is going to be your mid-chapter quiz, so you can start working on that. I believe it's just a front and back page.